Good day everyone. Today we will discuss about the concept and how to sketch the algebraic and transcendental function. Let us start with the derivative of a constant. So dy over dx is equal to d over dx times c is equal to 0, where c is a constant. Second, the derivative of power, which is dy over dx is equal to d over dx times x to the power of n, where n is a positive integer, stable integer. Okay. And the third derivative is product by dy over dx is equal to d over dx times u over v is equal to u times du over dx plus v times du over dv. Or you can solve like this. First times derivative of second plus second the derivative of first. So this is the formula. And now for the fourth rule is the quotient. In the quotient, dy over dx is equal to d over dx times u over v, where v times du over dx minus u times dv over dx all over v squared. Or you can write also high and low, where the low times derivative of high minus high times derivative of low over low squared. Now I have another problem. Y is equal to x cubed minus 2x squared plus 4x minus 1. The derivative of dy over dx is equal to the derivative of x cubed is 3x squared minus 4x plus 4. And this is your answer. Now we will sketch the graph by using the table of value. X. Now this is the answer of the 3x squared minus 4x plus 4. And this is the sketch of the table of value. Now, we will use the following rules to answer the given function. So, I will use the product rule. First, second, the derivative of first, the derivative of second. Input the first, t plus 1, and then t squared minus 1. The derivative of t plus 1 is 1. The derivative of t squared minus 1 is 2t. Now, first times derivative of second plus second derivative of first. So, t1 times 2t plus t squared minus 1 times 1, and we will get the answer of 2t squared plus 2t plus t squared minus 1, and then combine 3t squared plus 2t minus 1, and now we will sketch the graph of this answer by the table of value. This is the table of value, the result, and this is the result of the graph. As you can see, it's formed like a parabola. Now we will use quotient rule. By the given y is equal to w plus 2 over w minus 4. So the formula that we will use is VDU minus UDV over V squared, or low D high minus high D low over low squared. Now, I will use the high D low and low D high. High, put the W plus 2, and low, W minus 4. And the derivative of high is 1, and the derivative of low is also 1. And then W minus 4 times 1 minus W plus 2 times 1 all over W minus 4 squared. After that, let's simplify. W minus 4 minus W minus 2 all over W minus 4 squared. And now let's combine it. We'll get the answer of negative 6 over W minus 4 squared. Dy over dx. Now we will sketch the graph of negative 6 over W minus 4 squared. By the table of value, we will get the answer. And then the graph is look like this. Thank you.
Hi, this is how you solve the ln. So I will give you an example of an ln. 8 plus 3x. First, we have to master the formula for dy over dx, and that is dy over dx is equal to dy over dx dy over du times du over dx. In this equation, our y here is equals ln times 8 plus 3x, and our u here is 8 plus 3x. Substitute the y and u in the formula dy over du times du over dx equals d over du times the natural logarithm of 8 plus 3x times the d over dx, which is 8 plus 3x. Then the next step, we have to derive the y with respect to u and the u with respect to x. dy over dx equals to 1 over 8 plus 3x times 3. After finding its derivative, multiply the derivative of y to the derivative of u, then it comes up with the answer equals 3 over 8 plus 3x. So here's another example of log. Y equals log a times 3x squared minus 5. So the dy over dx here is equal to d over du, then log a times 3x squared minus 5 times 3x squared minus 5. The log a here is equal to log e, and multiply the log e, the answer of dy over dx equals 1 over 3x squared minus 5, then log a e times 6x. So the answer here is 6x over 3x squared minus 5 times log a e. After getting the answer, now we will sketch this graph. By using a calculator, mode 7, and type this. After that, you will get the values of from 0 to 5. And the graph is look like this. So this is the example of a log. Like in ln, it's the same formula dy over du times du over dx. But for the derivatives of log, it is 1 over n. Equals d over du log 5, then times 6x squared plus 7 times d over dx. The value of u is 6x squared plus 7. Then derive them. So the derive of log is 1 over ln, and the subscript 5 put here, and copy the 6x squared plus 7 times the derivative of u is 12x. Then multiply dy over du times du over dx. So you will get the answer of 12x over ln 5 times 6x squared plus 7. After getting the answer, we need to sketch the graph. Using the calculator mode 7, then input the answer 12x over ln times 5 times 6x squared plus 7. Then start with a 0 and end with 5. So this is the result in the table, and the graph looks like this. So here's another example of log, but now this is a trigonometric function. First, we have to write the 1 sine x times d over dx sine x. After that, derive the signs. The ratio of sine is cos x, then copy the sign denominator over the ln x 7. So after that, the answer comes up with a cot x over ln times 7. After getting the answer cotangent times x over ln 7, the graph of this looks like this.
We have another problem, which is find the dimension of a rectangle with perimeter 1000 meters so that the area of the rectangle is a maximum. Solution. So, let the length of the rectangle be x meter, the width be y meter, and the area will be a meter squared. So, the perimeter of rectangle is 1000 meter is equal to 2x plus 2y. Hence, which we will divide into 2. So what we get is 500 is equal to x plus y. Then transfer the y to the left side, y is equal to 500 minus x. And then the area is given by x, y, and then ax is equal to x times 500 minus x, and you will get the answer of 500 x minus x squared. Because y and x are length, we must have x greater than 0 but less than 500. The problem now reduced to finding the value of x is 0 and 50, for which a is a maximum. Since a is differentiable, the maximum must occur at an endpoint or a stationary point. So, dA over dx is equal to 500 minus 2x. Setting, now we will get dA over dx is equal to 0 gives x is equal to 250. And then this is the graph of the problem.
Good day everyone. So I'm going to teach you how to sketch and derive an implicit and trigonometric function. So this is gonna be our function. So first we need to derive one of each. So the 1/2 cosine 5x is we're going to use chain rule. So this gonna be our new function, and the sine for y we just derived it. It equals to 4 cos 4y prime. So y prime is also called dy over dx. So the 4xy, we're going to use product rule in order to derive it. So the derivation of it equals 4y squared plus 8y y prime. So here are the steps. So for our constants is equals to 0. So our new function will gonna be this one. 2 cosine 5x, this one. So we need to simplify it. So after simplification, the result is negative 10 sine 5x cosine 5x cubed plus 4 cos 4y dy over dx plus 8xy dy over dx plus y squared equals to 0. So after simplification, we need to separate the dy over dx from the other function. So 4 cosine 4y dy over dx plus 8xy dy over dx is equal to, so transpose this negative 10 sine 5x cosine 5x cubed. It's going to be 10 sine 5x cosine 5x cubed. So bring out the dy over dx and multiply it to this function 4 cos 4y plus 8xy is equal to 10 sine 5x times to cosine 5x cubed. So divide it in order to cancel cosine 4y plus xy. So cancel. So our dy over dx is equal to 10 sine 5x cosine 5x squared, cube rather, all over 4 cosine 4y plus 8x. Okay. So we are going to continue the graphing. So in order to get this, just input mode 7 to your calculator to get the table. So negative 5 to 0.33, just plot the points. After plotting the points, just trace it. So this will gonna be our graph.